Hello, now we're going to continue on with our work in coordinate geometry, and we are going to look at the perpendicular distance from a point to a line. And in this case we are looking at log tables page 19. So we've gone up a page, we're now on the top of page 19 in our log tables. And we are going to have a look at a few different ways that this type of question can get implemented. Now, if I have a point A, we're over on the left hand side of the screen, if I have a point A, and I have its coordinates are in the door 4, up the stairs 8. So I have a point A at 4, 8. And I want to know what the distance between this point and the line L is. I'm able to use the formula that we're looking at today in order to find that. So what I'm going to get is the distance from a point to a line. And often in the exams they will actually speak as loosely as that. So you're expected to know, if they ask you for the distance between a point and a line, they mean the perpendicular distance, because there are actually technically an infinite number of distances from this point up to the line that way, from this point up to the line that way, and so on. What they mean when they ask you for the distance from a point to a line is the perpendicular distance, and unless they are very clear otherwise, that's what they're talking about. Now, let's get the equation of the line L so that we can have a look at this formula. So I'm going to take this as an opportunity to remind you of how it is to read the formula for a line, or the equation of a line I should say, off of a graph. So I know that the equation of a line can be written in the form y is equal to mx plus c. So let's use that method for getting the equation of our blue line L. So I have y is equal to, m is the slope. What's the slope of this line? Well, if I run across by 1, I rise by 2. If I run across by 1, I rise by 2. So that means that my slope is going to be rise over run is going to be 2 over 1, or just 2. And c is the y-intercept. Where do I cross the y-axis? I cross the y-axis at 5. And it's positive 5. So the equation of my line L is y is equal to 2x plus 5. I've had to do basically no work to get it. So let's write that down. L is going to be y is equal to 2x plus 5. Now, if I look to my log tables, I'm going to see that the equation I need is, I'm going to write d perpendicular to remind myself it's a perpendicular distance. D perpendicular is ax1 plus by1 plus c all over a squared plus b squared. Now, again, we have these lines in here which mean modulus, or absolute value. If I look to my log tables, I know that I need to have my line in the form ax plus by plus c is equal to 0, and I need the coordinates of a point. That's my x1 and y1. So at the moment I have a problem. L is not written in this form. That's called our standard form, or our general form of our line. So we need to rewrite L into this format so that we can use it in our formula. So L, sorry, not equals, colon, y is equal to 2x plus 5. Rearranging, we would end up with 2x minus y plus 5 is equal to 0. Therefore a, from here, it's now in the correct format, so a is the number in front of the x, it's the coefficient of x, is 2. B is minus 1, careful that there's a minus there, we don't want to drop our signs. C is 5, and we have our point 4, 8. That's our x1 and y1, and we're looking for d perpendicular. So if we sub into our formula, we have absolute value of 2 by 4 plus minus 1 by 8 plus 5 all over 2 squared in brackets, pardon me, 2 squared in brackets plus minus 1 to be squared. Simplifying that out, I get absolute value of 5 all over the square root of 5. Now, absolute value means I'm always going to take the positive value out of here, but I can see that before I do that I have a plus 5, so regardless it ends up being plus 5 all over root 5. If I remember back to my work with powers, this is 5 to the power of 1 all over 5 to the power of a half. I'm dividing the same base number so I can subtract the powers. So I end up with 5 to the power of a half is equal to square root of 5, same way, same meaning. And this is a distance, so I should write units to guarantee myself full marks. Now, that's our work. And this is a little bit of a reminder of our indices or powers. So, connected to this point here where we have a number in absolute inside of our absolute value or our modulus, we have our point A, gives us a positive number inside that modulus. That means if I picked another number, we're coming down to this point here, points on the same side of the line have the same sign in D perpendicular. If I took a point B at 7, 4, it's on the same side of the line L as A is, so it would end up with a positive number inside of this modulus sign as well, inside of this absolute value. Whereas if I had a point C over here at minus 112, it's on the opposite side of the line L. It's on the other side of the line L, so it would end up with a negative number inside the absolute value sign when I went to get D perpendicular. So that means that you can use D perpendicular to figure out if points are on the same side of the line, they'll end up with the same sign inside the modulus, or if they have different signs inside the modulus when you get D perpendicular, it tells you that they're on opposite sides of the line, and this can be an exam question that they could throw in. So you're expected to know that. The other thing that we need to think about, which is a very common style of question, is if I have two parallel lines. If I have this line here, we'll call it line M. If I have line L and line M and they are parallel to each other, they have the same slope, I can see that that they both have a slope of +2, rise over run. It's the same for both of them. What's the distance between these two lines? Well, I don't have an equation for the distance between two lines or two parallel lines, but I do know how to get a point on a line. And the easiest way usually is to find where the axis crossing is. So in this case, I could see from the graph that the point 0, 5 is on the line L. So 0, 5 is on the line L, and I can use that fact then get the perpendicular distance from this point to the line M, and that will give me the distance between my two parallel lines. So even though I don't have an equation for the distance between two lines, because I know how to get a line, because I know how to get a point on a line, I can still find the distance between my two parallel lines. And again, how do we find an axis crossing? Well, in practice, let's do this here. The line L is given by y is equal to 2x plus 5. If I wanted to know where it crosses the y-axis, it would mean that x was equal to 0. When I cross the y-axis, x is equal to 0. So I'd sub that in, y is equal to 2 by 0 plus 5, y is equal to 5. So therefore I know that the point 0, 5 is on the line L. And now that I have that point on L, I can find the perpendicular distance from that point to the line M. That gives me the distance between my two parallel lines. That is the basics of our distance formula.